So today we're going to take a look at reviewing the topics from Unit 8. Let's go ahead and jump into our first identify the solutions. So remember, solutions, we could also call them roots, zeros, or x-intercepts. And that's all going to be asking you to do the same thing. What you're looking to see is where does your graph cross or touch, interact with, however you want to think of it, the x-axis. And so always start by identifying that x-axis. So in the case of our very first picture here, we do not have the quadratic actually crossing or touching the x-axis. So this is an example of a no solutions situation. Okay, so no solutions here. This problem is that special case where the vertex is the only point that actually lies on the x-axis. So in that case, 1, 2, 3, the x value of 3 is going to be your solutions. So when x equals 3, you could see, your brackets with the value there, but there's only the 1 at positive 3. Okay. In this case, our solutions, there are two. The first one is going to be at x being negative 2, and the second one's going to be when x is positive 2. So again, just x-intercepts, where do you cross the x-axis, and then list those points. These are not ordered pairs. When we use those brackets, that is telling you that this is a listing of points. Okay, so those are our solutions. Now, what are the zeros for f of x? Remember, f of x is just another way of saying y. So the zeros for this equation. So when you don't have a picture provided, we want to go ahead and graph in Desmos. Okay, so we're going to check the graph in Desmos. And so clicking over, we have here y equals, and then 3x squared plus 7x plus 2. And so hitting that home screen, we can see that our graph crosses the x-axis in these two places. And so I'm recording. I'm going to actually go ahead and use that decimal. So don't try to worry about changing it necessarily, right, to a fraction. We're going to have an easier time taking the fractions if they gave our answer choices in terms of fractions and turning them into their decimals. So the x-intercepts, we want the x values. Those are our solution points. And so the next one, notice that we didn't change our graph here. We saw this type of problem previously as well when we were looking at our factoring problems. So which of the following is true for f of x equals, and notice it's the same equation. So y equals in place of f of x, just knowing those are the same. But if we're looking for equivalent, right, that's essentially the task here, to determine which of these answer choices is equivalent to this. So these are our factored forms. So to see which ones are equivalent, we've seen this a few times. In Desmos, we're looking for overlap. So what we'd want to do is go ahead and graph this one. So we want that in, we could say line 1 here. We're going to graph that. And then we're going to compare in line 2. We're going to put in our answer choices. And we're going to look to see where do we have that overlap. So starting with our first answer choice, and I'm just going to leave this in there. Bringing up line 2, I am going to type a y equals. You always want to lead with that so that Desmos knows that you want it to graph. So coming in with our 3x minus 2 and then x minus 1. I'm looking to see, do I have overlap? So these are clearly not lying one on top of the other. So that tells me that this first one, answer choice A, can be eliminated. If you check answer choice B, the only change was in the first parenthesis. They changed to a plus. So we know it's not this guy. We just changed this to a plus. Still don't have that overlap. So let's see what happens if we continue to change our signs. So not overlapping. You see two different graphs. That's not overlap. Okay, so plus plus, I'm still not seeing overlap, but guys, trust me, it's going to happen. So this one, for when I look at answer choice D, notice that they switch the numbers around. So when you're looking at your review, the 3x plus 1, and then this was an x plus 2. Notice that swapping those values did get me that overlap. So overlap, when we say that, we're talking about a way to find if two things are equal or equivalent. If those graphs are on top of each other, so they pass through the same points, then we know that we do have equivalent, so true that this and this would be equal to one another. Okay, so that's what we're looking for there. Now, describing the transformations, we talked about comparing the graphs, right? So this is our parent function, starting off with that f of x equals x squared. So that's our most basic version of the quadratic function. If we look at g of x, that's our transformed function. So we want to compare parent to the transformed. The easiest way to do this is to just go into Desmos and begin with that parent function. So we leave that in line 1. And then in line 2, we'll go ahead and start putting in our transformed function. And we're looking to see what happened. And so for this first one, we can see that, if our parent function is this black curve, then our red transformed g of x function, it didn't move up or down, it didn't reflect, it doesn't even appear to be narrower or wider. The only thing that's changed is it slid. If we use the vertex, it went from 0, 0 to 5.3, negative 5.3. So in terms of using our descripting words here, so left, right, we would say that this moved horizontally to the left 5.3 units. So the only change that we need to talk about is that left 5.3. So when we compare them, that was the only change. So there's only the one transformation. Okay. Now, when we're going to do the same thing here. The only change is going to be in the parentheses again. So when we compare f of x and g of x just has this extra minus 4 inside the parentheses. So comparing that to what we just saw, similar in the sense that when we go vertex to vertex, the vertex started at 0, 0 and then now went right 4 units over to 4, 0, but no up down, no changing in the the vertical stretching or compressing or any of that. So we have one transformation, and that was a move of right 4 units. Okay. Now this one's a little bit different because we still compare to the parent function, but notice where this 7.2 is, plus 7.2. This is behind our function, so behind the x squared part of the equation. So it's not in the parentheses like this one was. So let's see what that's going to do differently for us. So here we don't have anything in the parentheses, but behind it we have plus 7.2. Okay, first we don't even see our graph, but we know that means we need to zoom out, right? So when we compare, always compare the vertex of one to the other. We didn't move left or right because it's still 0 and 0 for x, but you can see that the y values changed. The vertex moved up 7.2 units. We didn't change anything in front of the x squared, so it's still going to be no additional changes, just that our graph moved up 7.2. Okay. So now looking at our next question, which function best represents this graph? So this is a matching, okay? So best represents, this is going to be a match. And so what we could do here is simply graph our answers in Desmos, our answer choices, and match them. And look for which is going to graph exactly like this, okay? So we'll start with our f of x equals x squared plus 2x plus 4. So coming in here, taking that out, x squared plus 2x plus 4. So we can see right away that because this one opens up, it's not going to be a good option for us. So opening up, we don't want one that opens up. So then checking our next one, the only thing that was different is we threw a negative in front. Let's see if that fixes it. Aha. Okay, so we can see that our graph is going to have those as its x-intercepts and a maximum point up here at 1, 5 and an intercept at 4, and so that's looking perfect for us. Also, if you recall from our transformations, if you don't have a negative in front of your x squared term, that graph's going to open up. So that negative is going to give us what we are looking for here, okay? All right, now we're on to this negative root, positive root business. When you're looking for a root, that's just an x-intercept. And so recall that we would need to get our equations equal to 0 in order to graph our equation and see what our intercepts actually were. So we always want to zero out our equation. We need everything on one side. So this positive 2, we need to move him over. So we're trying to zero him out. So the opposite of that is going to be to do a minus 2. That's going to go to 0 for us. And so we get that magical equal 0 that we're looking for. And then for this situation, once we brought the 2 over with his new sign, we're now ready to graph. And so we will graph, we need that y equals, but we're going to go ahead and graph to see what our roots are, which is really just those x-intercepts, right? So taking a look at this one, we've got minus 3x and then minus 2. Looking for where our graph is going to cross, home screen here, but where our graph crosses the x-axis, we have a negative 0.5 and a positive 2. So don't overthink this. When it's asking for the negative root, it is literally talking about which number of the 2 is negative, which is the positive root. So just separating and identifying correctly which is your positive and which is your negative.